there may exist a point in the universe where space and time collapse together into something beyond comprehension, not just extreme gravity or high energy, but a place where the very structure of reality stops functioning. Scientists believe such conditions might exist inside black holes, or at the beginning of the universe where the rules of physics reach their absolute limits. Space and time are not separate. According to modern physics, they form a unified fabric called spacetime. This fabric can stretch, bend, and curve under the influence of mass and energy. But under extreme conditions, this fabric may not just bend, it may collapse entirely. Black holes offer the closest example of this phenomenon. At their centers lies a singularity, a point of infinite density where spacetime curvature becomes infinite. In this region, our current theories fail completely, and space and time lose their conventional meaning. As matter falls into a black hole, it experiences intense gravitational forces. Time slows dramatically relative to outside observers, and space becomes increasingly distorted. Near the event horizon, the boundary of the black hole, these effects become extreme and visible. At the singularity, the distinction between space and time may disappear. Directions lose meaning, and all paths lead inward. The concept of where and when becomes undefined, marking the collapse of spacetime itself. The early universe may have passed through a similar state. Immediately after the Big Bang, the entire cosmos was compressed into an extremely hot, dense point. During this phase, space and time were not structured as they are now, and conventional physics cannot fully describe the conditions. Quantum mechanics suggests that at extremely small scales, spacetime is not smooth but fluctuates constantly. These fluctuations, known as quantum foam, could become dominant near a collapse point, creating a chaotic and unstable environment. In such regions, cause and effect may break down. Events could lose their sequence, and time might not flow in a single direction. This challenges our fundamental understanding of how the universe operates. Some theories propose that space and time emerge from deeper, more fundamental structures. If this is true, their collapse could reveal a hidden layer of reality that underlies everything we observe. Gravitational waves, ripples in spacetime caused by massive events, show that spacetime is dynamic. In extreme conditions, these ripples could become so intense that they destabilize the fabric itself. If spacetime collapses, distances would lose meaning. 2 points could become indistinguishable, and motion between them would no longer be defined. The universe would no longer behave as a continuous structure. Time collapse would be even more profound. Without a consistent flow of time, processes cannot occur, and change becomes impossible. The universe would exist in a state beyond progression or sequence. Some models suggest that such a collapse could lead to the creation of a new universe. The breakdown of spacetime might trigger a transition into a different state, possibly restarting cosmic evolution. Others propose that these collapse points are isolated, hidden within black holes, inaccessible to the rest of the universe. They remain as regions where reality behaves in ways we cannot observe directly. The study of these extreme conditions is one of the greatest challenges in physics. A complete theory of quantum gravity may one day explain what truly happens when space and time collapse together. The point where space and time collapse together represents the ultimate boundary of knowledge. Beyond it lies a realm where our understanding fails, and reality transforms into something entirely unknown, reminding us how much of the universe remains a mystery.